So today, I'm going to give you a kind of a short enough presentation. I think Shannon has given a nice introduction. I've been kind of looking at these technologies for the last numbers of years, actually probably the last decade and a half at this stage. I'm starting to get old. Um, and my background really comes from an academic setting where we've been looking at the types of data technologies that we have, how they need to evolve, and then trying to understand where their role is within society and how they fit. So I kind of try to straddle between looking at technology development, but then the innovations that can drive that and how we try to get it adopted. So today's kind of presentation, Shannon kind of said it was a mixed group of people, some maybe more on the organizational side, some more technical people. So I'm trying to give a little flavor of different types of challenges and opportunities that actually exist with data spaces, recognizing the fact that you're already on your data spaces journey. You either have a few established or you're looking to establish them. There's no need to define what a data space is again, but maybe to look at some of the nuances here. What's going to be different about what we try to do with data spaces, and what are the challenges and the opportunities that present themselves? So the first thing I kind of want to talk about is the notion of trying to manage data and the evolutionary competition that exists here. So the evolutionary challenge that we have here. So no matter how good our data technologies are, as a society, we keep creating more data and more challenges associated with that data. So I just want to dive a little bit into that, just to kind of pause and reflect on what are the actual opportunities and what are the challenges that exist there. So the first thing is, even though we have incredible amounts of data, when it comes to using data to power AI kind of solutions, one of the biggest challenges that industry have and still have is this notion of not having enough of the right quality, the right style of data to be able to train and to use for their AI models. And one of the reasons for that is to do with the fact that the underlying technologies themselves are challenging and are disconnected from their AI efforts within their organizations. With the data that they do have, they still have many challenges with that around things like imbalance, bias, um, limited variability, data drifts. So that there is a very significant challenge within organizations. And when you're looking to build an AI solution, the first thing that we're seeing is that a lot of these projects are failing. A lot of them are not really delivering value. And anything between, depending on the studies that you look at, anything between about maybe 30 and 80% of any particular AI project um, will actually be focused on data preparation, data staging, data quality issues. So data has a massive effect on your average style of AI project. Now, I'm obviously excluding things like large language models and things there where the compute becomes a very, very significant part of the cost. But beyond those very large kind of foundational models, for most organizations, they invest a significant amount of AI projects into data. And the reason for that is because they really haven't been investing the necessary levels of resources in their data infrastructure inside their companies. So by trying to deploy AI systems, what they see is, well, actually, our data architecture, our data management approaches, they aren't up to scratch to be able to do that. Hence the need for a significant amount of investments there. And that's quite important in the context of data spaces. And well, what we need to think about is, why is that? Why is it so difficult to manage data? What's the challenges that we have with it? And it's useful to reflect on that, because the problem we have is typically data is created in a very distributed and decentralized manner. So you have physical separation of data, which a data space tries to kind of to solve, where you've got it stored in different systems in different organizations, and you want to be able to share it. So there's that distributed challenge, but that's actually not that hard to solve. In the grand scheme of things, there's actually things that are much more complex than just bringing and physically exchanging the data. Even though that's not trivial, there are technologies that can do that. There's many different types of technologies. One of the biggest challenges is this notion of decentralization of the semantics of the data. So you can have data describing particular entities or particular parts of an organization or a particular environment. And if it's created by different teams, different individuals, different organizations, people with different backgrounds, they bring multiple perspectives to the table. So you've got this challenge around conceptualizations, multiple different conceptualizations of reality with ambiguity, vagueness, inconsistencies, and trying to bring together that kind of semantic interpretation, which is actually incredibly challenging and is much more of a human problem than it is a technology problem. And that's something that's fundamentally difficult and challenging about data. So this notion of it being distributed, of it being decentralized, both physically but also conceptually as well. That's a real challenge that we have. Another problem we have is the notion of interoperability and the different types of challenges that present itself here. So we often talk about interoperability of data, of services, but ultimately what you are looking at to have true interoperability is higher levels of processes within organizations as well. So how does one process work in one organization? Is it interoperable with another process and another one? And then business level interoperability as well. This is why it's such a difficult challenge because you can have interoperability at the systems level, but at the process and at the organization level, unless it exists there as well, you'll have challenges. And that is one of the benefits that data spaces do bring it is at least a conversation about what are the kind of unified processes or the agreed processes that we need between organizations when we're sharing data between them. Some of the challenges that kind of exist there that data spaces are trying to resolve, but haven't, I would say, fully gone or haven't got fully fledged solutions there, are notions of persistent identifiers. How do you identify the same entity, the same person, Ed or Shannon, or Andy, across different organizations? Who actually manages that persistent identification? Is that something that's done at a company level, at a data space level? Is it potentially something that's done at a national level as well? So this notion of identification is a really interesting opportunity, but also something that needs to be figured out as well and agreed upon. There's other issues around data quality and the level of data that quality that is appropriate for different types of applications. So what's appropriate for search and browsing for products may not be the same as what's required for engineering solutions for bridges or for flying planes. So understanding what data quality means in the context of use is another challenge as well. So the interoperability is a key problem. The other thing that we have with data is not only have we, like I think a key challenge is the notion of the complexity of the models that we're actually creating here. So on the left here, like if you go back 20 years ago, when at least when I was trained initially, we were trained in relational databases. You had nice entity relation diagrams. You had tables. You had relationships between them. You talked about cardinality, and typically those technologies were designed to work with entities or rows that would have maybe tens to hundreds of attributes. If you zoom forward to 20 years since and 25 years now, the data that we're actually modeling is much, much more complex. We're not talking about tens or hundreds of attributes, but we're talking about thousands to millions of attributes of data that's been created inside organizations. Lots of challenges around duplication, ambiguity. But if you think of it like if you had a digital twin of a human trying to capture all of the different aspects of that human and the different types of variations that would exist, you're looking at millions of different attributes um, around a digital twin of humans. So this is a really complex challenge to be able to work with. And fundamentally, that data does not fit into relational databases anymore. It's very much around graphs. It's around large open schemas that are changing, that are evolving. And that's incredibly difficult to manage from a data management perspective, particularly around conceptualization, integration, and bringing that together. So what we have is today is we have this notion of a long tail of data, as you can see here on the right, where we have some data that's frequently used, um, and then we have this long tail of attributes for entities. And the challenge that we have is that our traditional approaches towards data management, things like relational databases, master data management, these types of techniques are very good at dealing with the head, but as you try to scale it to deal with the tail, it becomes much more costly. So every additional attribute that you're trying to map or to integrate or to link becomes more and more costly to be able to do that from a semantic integration point of view. So this is a real significant challenge that we have, and it's something that needs to be considered. And there are some opportunities for us to kind of explore solutions to this. But this is the fundamental challenge that we have from an evolutionary point of view is that the technologies themselves, even when they do get better and they can handle more scale, we're just creating more and more data to be able to work with. So when we look at at Dataspaces, one of the kind of fundamental, I would say, seminal pieces of work from the academic community was done by Halavi Franklin back in about 2006. And they looked at what are the challenges that you have when you're trying to um, share and exchange data at scale. And they basically, it's a useful analysis to look at two different types of concepts. One is the level of administrative proximity between different entities. So this is basically how much coordination do we have between our data sources. And the more coordination we have, the more assumptions we can make about data access, data quality, consistency. Um, and then the other challenge that we have then is what is the level of semantic integration that we expect to have? So how much do you expect your schemas to be able to match up um, versus them not being connected at all? And what's interesting here is when you actually start analyzing different types of technologies around this level of coordination and the level of integration that you expect, well, the two extremes that we'd point out is the kind of like the database management system. You have, full control, or you should have full control over the or high levels of control over the sources that you're using within a database management system, and you are expecting them to be highly semantically integrated so that you can run a query over multiple tables. At the other extreme, what you look at is kind of is web search. So web search basically doesn't have much coordination over the different sources that work together, but what you do have then is basically also low levels of semantic integration. And this is kind of the dichotomy that we have. The more control and integration you want, the higher the costs. The less control, coordination, the less integration, the lower the costs. And that's really the kind of challenge that we look at. If you look at data, open data portals, they actually have a little bit more coordination between them, but effectively they work at kind of web scale kind of philosophies, web kind of centric approaches. And that's interesting to look at as a similar technology to data spaces. Where do we expect our data spaces to fit? Do you expect a data space to be very similar to a relational database, or do you expect it to be something different, like a web search? And that's kind of a key design philosophy to look at and to try to understand. What's interesting about levels of coordination is when you look at the open data portals, which I would say they are probably, the previous generation of kind of large scale data sharing initiatives that kind of came. Data spaces are obviously an evolution of that. But this was a study that was done, and I've sneakily taken the slide from a photo from colleagues in UPM in Madrid that looked at the Spanish data portal. And what they wanted to understand is what was the level of standardization that actually existed within that portal. And what you can see here is that only about a quarter of the data sources actually were documented, and the vast majority of the data sources that were put up there were not documented. Now, what's interesting about that is that one, open data kind of very much came from the web philosophy of, well, just make the data available first. Don't try to document everything as a barrier to making it available, but put your sources up there first and then try to improve them. So they saw about 25% of it was standardized, and the rest of it was just made available. And that's an interesting kind of perspective about what's the level of effort that is it better to have access to 25% of the data or to have access to all of it, regardless of the level of standardization. And that's very much a philosophical thing that we need to think about when we're developing data spaces. Do you want to be able to have all data available, even though it's not standardized or in an agreed format? Or do you want to limit it to maybe high quality data that is standardized and is following a fixed and agreed upon schema? Very much a decision for the design of a data space. The other types of challenges that we have with data as well is this notion of subjectivity in data. So I know this community is very much looking at research data, and depending on the type of research that you're doing, we do have more, I would say, fact-based approaches. But if you start looking at more qualitative sources, surveys, opinions, that type of research data, you do have an awful lot of subjectivity that comes there. So from facts to alternative facts, opinions, different interpretations. And the challenge that we have here is that this is actually something that is very common with users now in terms of looking and interacting with information systems. The notion of subjectivity in the query is something that actually exists particularly when you start looking at web searches. So for example, here, if you're looking at a subjective query for hotel prices, so if you're looking for a reasonably priced hotel in London or in Sydney, the notion of reasonably priced for me as a professor is one thing. For a student, reasonably priced is quite different. For a billionaire like a Bill Gates, it's a very different kind of notion of reasonable. So the notion then of trying to personalize the query mechanism to be able to support that subjectivity and that level of opinion or that kind of domain perspective becomes quite important as well. And this is another challenge that we have to recognize that this is the level of querying that our users expect now from our data sources. So all of this kind of ties to this notion of the concept of managing data in the same way that we would have in a relational database system has changed fundamentally. Um, our end users are expecting to be able to have queries that support subjectivity, that support different types of data, that support the long tail of data. And how do we start trying to deal with that? Um, so there was actually a really interesting article from Pat Holland. This is probably about 10 years old at this stage. He was in Microsoft at the time, and they were talking about the notion of good enough approaches to data management. So if you have lots of data, if you actually have too much data, then a good enough approach is probably good enough for what you're trying to do. And it's this notion of relaxing the level of quality that you expect in your query. And it's a very interesting kind of concept. When you look at data spaces, again, going back to the fundamental um, seminal papers from the academic community, it wasn't about data integration. It was actually more about data coexistence. So the early kind of approaches was recognizing that with all of those challenges that you have, it's really difficult to scale that integration because ultimately, no matter how many schemas you define, no matter how many communities you get to agree on a schema, even if you get everyone to use it, we still create more data. There will be new sources, there'll be additional sources. So rather than trying to say that everything has to be in a single schema, it's great if you can have a schema, it's great if people agree on it, it's great if you can map your data to it. That's fantastic. And it's probably likely 30, maybe even 40% is a great success to have that level of mapping to your schema. But what do you do with the rest of those data sources? There's still going to be more data not in the schema than in the schema. So this is the notion of coexistence. How do you get data sources to coexist together? So the idea here being that if you look at our long tail of data and we have our traditional approaches to data management, can you start using more approximate best effort web search style approaches to be able to create technologies that actually can tackle that long tail and can reduce the cost? Um, and that was basically one of the kind of perspectives with data spaces is that, again, from the traditional literatures, how do you start investigating those best effort approaches? What are the opportunities with them? Um, these are the kind of things that we've been looking at for a long time in my own research, where we looked at semantic models for interpreting for interpreting data to be able to do it in a computational kind of approach to semantics. We've been probably doing this for about 10 years. Um, and what we actually found is that we had reasonable levels of success. But once we started looking at things like large language models in the last 3 years, and I'll talk more about these later on, but the level of support that's actually, sorry, the level of opportunity that's there now is actually very, very significant when you start using large language models to be able to help you with interoperability to be able to do good enough approaches. And this is just one example of some work that we done last year with some colleagues in Fraunhofer, where we were looking at shackle shapes, so basically ways of being able to describe a piece of data, and basically asking um, ChatGPT to be able to take one and to be able to generate the shackle rules for it. And what we found is that it actually done a pretty reasonable job. There was a couple of small errors in it, but the notion of being able to get computational approaches to helping to support the management of data is definitely something that is on the near horizon. And we actually, even since this now, there's actually been a good bit of work that actually has moved these techniques on. So the I guess the kind of key message from this particular part of the talk is that we have a constant battle with trying to manage data. It's never going to be fixed by having everyone move to a single schema because of the nature of how we create data and the nature of us creating more data in this distributed, decentralized ways. And if we start to look at additional tools to be able to support that around good enough interoperability, good enough approaches, I think there's a lot of opportunity there for us to be able to work with that long tail and to be able to complement the existing technologies with it. So the second message I want to talk on is a little bit more for those that are maybe have just established a data space, you have something in place, and you want to figure out, well, then what do I do now? And it's really about looking at how do you shift your mindset from a sharing centric mindset to a value centric mindset. And this is actually quite relevant in the context of the common European data spaces that have been established, where we actually have communities there now, we have infrastructure in place, and the question is all about, well, what's the benefit, what's the value, how do we actually support the user? And this is a key opportunity, but also challenge for us as well. Once you have the capacity to start sharing, you have to start showing the value of sharing to your stakeholders, to your users, to your funders. What's interesting here is when we start looking at what does value mean for data, what you find now, at least, is that AI techniques and different types of data analysis techniques are really about extracting value from data. And when we look at the opportunity that we have with large quantities of data in a data space, and you start looking at generative AI techniques, there is a really, really close connection between these. So much so that I would say that generative AI foundational models will be the killer app that delivers value for data spaces. So let me explain that a little bit. So I'm not too sure. I can't see the room, but I'm sure maybe one or two people might have used VisiCal in the room. But VisiCal was basically the first spreadsheet piece of software, and it was the killer app for the Apple II. Basically, this was the software that drove an awful lot of sales for Apple II. When you look at the Windows, the Wintel empire, nobody really wanted to buy Windows. Why would you buy Windows? What does it do? But Microsoft Office, Word, and ultimately Excel and the other tools that came with it, that was the killer app. The reasons businesses went with Windows was because you wanted to be able to access the Microsoft Office suite. That was the killer app that drove it. When you look at the internet in the web, it was Netscapes, it was web browsers that were the killer app, that basically moved it from something that was nice and maybe a toy example to something that could actually be used to share documents, share information, to drive businesses, to create businesses. The the web browser was the killer app of the internet. And then when you look at mobile phones, the phones themselves, you know, they still allowed you to send texts, make calls, but smartphones, by introducing the App Store, they changed it from being a phone to actually being a mobile computing device. So the App Store is a kind of killer apps for smartphones. So in the area of data spaces, I think generative AI will be that killer app. To give you a little bit of an idea of what that means, I think it can fundamentally change our human paradigm, sorry, our human data interaction paradigm. So again, I can't see the room, but I definitely know Shannon probably recognizes this. So if you don't know what this is, back in 1995, this was the center of the web. It was Yahoo. It was, if you wanted to find out about anything on the web, you would go to Yahoo and you would basically search its taxonomy. So what Yahoo did was it created a taxonomy of different websites where people would basically submit a website to a particular category. So, for example, if you had a web page on Liverpool Football Club, you would find probably soccer because it was American based, soccer teams in England, and then you would have web pages there on Liverpool. What was really good about Yahoo was it was very, very high quality web pages made it in here. At the time in 1995, there was 100,000 web pages. It gave you exact results. It was the same as a database query. These were exact results. They were human curated. They were very, very high quality, all based around this taxonomic structure. If you fast forward 3 years later, 1998, we have about 2.5 million web pages. So we've gone from 100,000 to 2.5 million. And suddenly Google popped up. And I'm sure everyone's familiar with this. But the fundamental change with Google over Yahoo was that you moved from this rigid structure that was humanly curated to a search paradigm where you enter keywords, you get back search results, and those were approximate results. They weren't exact results. They were approximate. You could say they were good enough. They didn't give you answers. What they basically gave you were web pages that were highly relevant to the search keys that you'd given. The key thing here is that there was no humans involved in the process, really. What you had was the results were computed. They were basically analyzed using PageRank and other algorithms to figure out what are the best web pages for a particular result. And that was a game changer. And this became the primary way now that we interacted with information. Zoom forward about 14 years, we went from 2.5 million web pages to about 700 million web pages. And what Google recognized is that people were no longer searching for keywords, but people were putting a lot of questions directly into Google. What's the best hotel to be able to stay at? What year was Marie Curie born in? People would put questions in and they were looking for specific answers. It wasn't as relevant about what web page had the answer. Many web pages would, but they tried to move those answers actually into the search engine itself. And they've done that by bringing in these knowledge graphs. And you'll still see them there today, where there's basically a knowledge graph that's been displayed to you, giving kind of key facts and information about the particular search query that you had. What was key here is that it moved from having the approximate search results, which were still there, to also having exact results, because that knowledge graph was curated in the background. It used to be called Freebase. It was actually an open knowledge graph, and it was mixing this kind of computed results with crowd results, and that's basically been the dominant paradigm for interacting with information. If you can imagine, if any of you had a data space today and you could provide that level of functionality to your users, you'd be quite happy. Chances are, you know, we're mostly in the area of looking at a kind of search-based interactions, and actually many of it is still in the structure where we're basically structuring different resources that we have in our data space. But our users would be expecting that more kind of knowledge graph, kind of question answering kind of approach. But what we've seen in the last 2 years, 2.5 years, is that it's fundamentally changed again. So large language models, ChatGPT, Gen AI, we've gone from a world where we had 700 million web pages to about 2 billion web pages today. Effectively, these models have the entirety of the web plus everything that they could possibly put into them inside in the model. But you've moved from even questions, even asking what year was Marie Curie born, and well, why do you need to know when Marie Curie was born? Well, I need to write a paper on Marie Curie. To now you're able to actually have a conversation. Well, can you help me write a paper on Marie Curie? So the notion of searching is even changing. Why are you searching? Because I need to create content. I need to do something. The models are able to help you support that. So the paradigm of that human data interaction is changing. It's moving from search to content creation. Um, but it's also interesting to look at it from the point of view of, well, is this an approximate result? Is it a computed result? Is it an exact result? And this is very much where there's a lot of questions and there's a lot of, I would say, innovation and opportunity there. But that notion of how we interact with data has changed. And what we need to look at is basically how will these Gen AI kind of techniques, how will that work with things like data spaces? How will we actually be able to change how our users interact and work with the data that's there? I guess the analogy that I'd look at it is the computer on the Starship Enterprise for the next generation. I'm not too sure there are any next generation fans in the room. Um, but basically, if you remember that TV show, they would sit down, they'd talk to the computer about what they want to do, what the problem they were trying to solve. They'd ask it to do tasks, it would come back. That's there today. We can do that today. So we very much are in that world. But the biggest challenge that we have here is this notion of hallucinations, inaccuracy on the information that's there, inappropriateness of the information. And really that's caused by limitations in the training data and the algorithms. It's caused by limitations maybe in the architecture that's looking more at what's the next best token to use as opposed to what's the right token, or what kind of reasoning can be done on those tokens as well. But we're even starting to see that change in the last couple of months as well with new architectures. But that really ties back to the importance here of data. Um, Interestingly, even with all the benefits that are there, um, ChatGPT can be incredibly persuasive when it does create content as well. So when you ask, this is an article that was on LinkedIn a couple of years ago that talks about the benefits of playing an accordion while riding a motorcycle, and ChatGPT will absolutely try to convince you of the importance of playing the accordion while riding a motorcycle. So there's a real danger with the technologies themselves, but you can see the potential that's for them there. There's also challenges around these models in terms of data governance. How do you bring together what we would expect to have in terms of licensing, of consent to be able to use data, of recognizing open and private data, data that's free, data that needs to be paid for, and basically how do you marry that with the construction, design, and execution of those AI models as well. So this notion of data governance and AI governance needing to kind of come together becomes quite important. And in the context of data spaces, that's incredibly important because one of the key things you'll see from the modern data space movement is this notion of data contracts, consent management, usage management, and basically being able to provide a much stronger layer around data governance that can then be used to support AI. When we're looking at foundation models and AI models, this is just a quick piece of work that was looked at the trustworthiness of them, the different types of trustworthiness that you need for these AI models, things like privacy, transparency, robustness, fairness. What's striking here is almost all of these tie back to the underlying data that was used to create those models. So when you think of it, the importance of data is central to it. This is some research that we did with a company in the area of customer experience for call centers, and basically what you find is that the underlying trustworthiness of an AI model is effectively directly connected to the trustworthiness that you have in the data that's been used to train it and to be able to support it. So the critical thing there is how do you bring together this end-to-end management of data and models together. So you can see the importance if you want to have high quality AI systems that are delivering value to the user, the better the quality of data that goes into it, the more controlled it is, the more understood it is in terms of the biases that exist there. And bias isn't necessarily a bad word because a bias can also be a signal for a particular population as well, but you just need to understand what those biases are. So basically data quality becomes kind of core of trustworthy AI systems. So in the European context, what we're doing with the Commission is very much looking at this symbiotic relationship that we have between these established data spaces that we've put in place, the AI systems that we're looking to build, and recognizing that there's a symbiotic relationship between these both. So data spaces can provide high quality training data, they can provide a community of users and owners of that data, and they can provide a clear data governance and compliance mechanism for AI systems. But at the same time, AI systems can provide those tools to support diverse data space tasks. They can speed up the innovation cycles for extracting knowledge and insight from multimodal data, whether it's text or images. And basically, they can provide that knowledge foundation to be able to work with that long tail of data. So, looking at those good enough approaches, how do you work with all the data that exists in your data space, whether it's in a schema or not? But then these generative AI approaches can help to support that. When we look at it from the point of view of working with an AI model, the data space itself can be used. You can take all the data in the data space that you're able to use. You can use it to build and train a foundational model by pooling it together. And then you can take that model and adapt it to different types of downstream tasks that you have in your data space as well. So everything from data cleaning to data summarization to search and querying to results summarization. So basically generating those types of tasks. And this is an approach that we've been using in Galway now across a number of different data spaces to build very specific foundational data space models to support the operation and implementation of data spaces. I'm not too sure if you're familiar with this, but the Data Space Support Center has identified different building blocks that you need to be able to implement a data space. They've broken them down into business and organizational and technical building blocks. And what we found here is that when we look to see, well, is there a role here for generative AI approaches to be able to help in the delivery or the implementation of those blocks? What we found is that yes, for the technical building blocks, there's lots of areas where generative AI techniques can help. But interestingly, on the business and organizational side, there's lots of areas where generative AI tools can help to support that as well. very simple in the area of even summarizing data contracts, proposing data contracts between different entities, helping to fill out um, data cards to be able to use in data catalogs. There's lots and lots of opportunities here for AI to simplify the implementation and design of data spaces. So ultimately, what we need here, and this is kind of an active area of research, but it's actually happening um, primarily within industry as opposed to within academia, is the need to bring together the life cycle that we have for data management and the life cycle that we have for building AI systems. So we need to have this unified data and AI lifecycle, and specifically within the area of data spaces. This, I think, creates a great opportunity because of the collaborative sharing nature of a data space means that the life cycles there are designed around sharing and exchanging data resources, the use of those data resources, and then that infrastructure can be used in to build AI models that are trustworthy, that have consent, that are following copyrighted and different types of constraints on the usage of the data. So that's really the opportunity and the benefit there. So then finally the last point, I've got maybe about 5 more minutes in the presentation, is to look at the opportunity for this global data space and the importance of international cooperation and the fundamental reason why I got up at 5:30 this morning to talk to you guys in Australia is to emphasize for us to be able to do this, it's something that needs to be co-created and co-governed across the globe. And there's many opportunities for participation in these activities. I'm just going to give a couple of different things that I think are important for the community in Australia to engage with. I know many of these you're already engaged with as well, but the doors are primarily open in most of these. The first one is the Data Space Support Centre. So that's helping to implement the common European data spaces within Europe. It does a lot of work in the area of building blocks, which I've just shown you here. We're also looking at things like design principles and best practices, and that's very much done kind of in an open, co-created kind of way. We have different working groups that you can participate in, and those are useful to understand not only but what's the collective thinking within the community around the best practices for, let's say, interoperability, but it's also a chance for you to have your voices shared there as well. So I would absolutely encourage you to participate in the activities of the Data Spaces Support Centre and get involved in those kind of co-creation activities there. There's also an awful lot of activities happening in the open source and standardization world as well. So the Eclipse Data Space Protocol is an open source project that's connected with IDSA and with others. I think it's a really interesting tool. It's very useful. It's not the only way to build a data space, but it's definitely, there's a lot of insightful learnings there as well, and many organizations are happily using that. In terms of standardization, we have the W3C has a data spaces community group, which is good to get involved with as well. It's a little bit more from the web philosophy, so things like looking at things like RDF, linked data, Shackle, ORDRL, those types of W3C standards and what they mean for implementing a data space. But that's a nice community to get involved in if you're interested more in semantics. And then also to point out other things that are happening, and not quite, I would not quite a standard, but more of a de facto standard. So looking at the Model Context Protocol, so MCP. I'm not sure if anyone in the room familiar with MCP, but if you're not, I would highly recommend you look at it. MCP is possibly a candidate to deliver a global data space on a de facto standard. So effectively, MCP allows us to connect different types of data resources into agentic AI models. So if you want to have an LLM connect to a particular source, you use MCP to connect that in. It's very lightweight. It's very simple. What's impressive about it is not necessarily the technology itself, but the level of uptake from industry from it. So this notion of a de facto standard um, may in fact be something that could be built upon. So looking at MCP, I think is a very, very interesting development for data spaces that will bring us to a much broader set of technologies as well, because the level of support for MCP is increasing based on the need of AI systems to connect to more and more data sources. So I would absolutely encourage you all to see what's happening there. Also with the OpenAI API as well as another interesting one to look at. And then finally, something to look at is this notion of governance models. Um, And I think this is interesting because not all data spaces, not all data ecosystems are the same. They can be designed in very, very different ways with different types of governance models, but also different types of technology implementations as well. I'm just going to give a couple of very quick examples of that. So if you look at, so this basically matrix here talks about who controls the data resources. You know, do you have centralized control or decentralized control? And what's the interdependency within the ecosystem? Is it a reciprocal interdependency or is it a pooled interdependency? So what's interesting here is depending on what the dynamics are in your ecosystem, you have different ways of wanting to design your governance. So the first example here, the top left, is very much centralized with a reciprocal kind of support. The example I give there is Skywise. So Skywise is from Airbus. Basically, Airbus is a large aircraft manufacturer, and Skywise is a data space that basically supports their supply chain, their extended supply chain. Because you have that kind of central keystone figure of Airbus, they basically get to say, well, here's our schema, here's our connectors, here's how you do it. And everyone in the ecosystem's happy to do that because they're all dependent on Airbus. They're all contributing to that supply chain. So it becomes easier to design that in a more top-down kind of approach. Um, Similarly, the European health data space is mandated by legislation. Each country has basically a single authority that's identified to be able to participate and to provide federated kind of support to basically make data available at a national level for that data space. So that gives you the kind of a more federated approach. If you look then at the more pooled ones, the top right hand corner there is basically, I would say, open data portals where you have lots of different portals, all with different organizations behind them. There's a certain level of commonality across them due to the technology platforms that they use. So they're either using CCAN or they're using another, there's one or two other open data portals that are there. So they all roughly follow similar types of format, but they have a distributed ecosystem between different actors. And then you have the kind of more coalition approaches. So GEOS is a good example of that. Although I'm not too sure if we classify it as a data space, but it's definitely a data ecosystem where basically you've a coalition of organizations pooling Earth observation data together. And that is, but I think GEOS actually is moving towards more of a data space approach. I guess the key thing here is that sometimes when you look at, you know, the discussion on data spaces, there's an assumption that everything is top down and will look the same. But the reality for the ones that are actually up and running, there's a lot of diversity in the governance, there's a lot of diversity in the technology implementation. Yes, we're trying to move towards interoperability between them, and there are things like the data space protocol that supports that, but not everything looks the same. What's important is to recognize, well, what is the natural set of relationships that exist between those stakeholders in the ecosystem, and then try to replicate that as much as possible within the design and implementation and governance of your data space. So it's an interesting thing to explore, and this is something that is constantly evolving as well as we're establishing more data spaces. And then finally, one of the research challenges that will exist here as well is this challenge that we will have with interoperability of different data spaces. So will the health data space be able to connect to the Green Deal data space, to be able to connect to the mobility data space? And that is an ongoing challenge that the data space support center is looking at. And there are some tools there that can try to support that as well. So it's an interesting thing to look at locally within Australia to do think about, well, if we are establishing different data spaces with different approaches, try to think of what's the possible roadmap to ensure that we do have interoperability either by design at the start or in the future as well. And this is a research project we have at Fraunhofer that's trying to explore the different tools that might be able to support that process. So just a final thought from me. Um, to kind of give the context of what we're trying to do when we talk about data spaces in the broad sense, as I say, I've been looking at this for over 10 years at this stage. But if you go back to the web, like the web effectively appeared, I felt like overnight in the early 90s. But the reality of the web is that, you know, the technologies that it was built on, you go right back to 65 with, you know, WANs and the development of IP. And it took a long time to be able to develop, you know, the internet protocol that we use today. Um, Internet protocol, there was many competing standards for IP. And basically, there was a lot of politics that ended us up with one single standard that was there. And that took the best part of 30 years to be able to do that. It's important to think of that in the context of what we're trying to achieve with data spaces as well, because it is a similar level of infrastructure. If you want to build a global data space that allows data to be more seamlessly exchanged between different participants, it is that level of project. Back in 2020, as part of BDVA, we did do a white paper that tried to figure out what's the 10-year journey along that. And this was kind of our very, very high level roadmap that would identify some of the kind of key things that we need to do. At the time, that was as a 2020. We, I think, in the first kind of 5 years of this, we've probably seen most of these things happen. We have seen convergence in the technologies to things like the data space protocol, that moving towards standardization. We have started to see deployment in the last year or two of data spaces within Europe. Now, what we really see is the kind of key challenge going forward is experimentation to deliver value, and also awareness. How do you get more and more participants engaged in data spaces? How do you get more organizations participating, understanding the benefit, and then starting to drive them as well? So we're probably, at least on this roadmap, about halfway through the journey, but there's still a lot of work to go. But it is as they say, at least a 10-year project, if not potentially longer. And that is everything for me. I hope somebody you got something out of that in terms of the challenges and opportunities that exist with data spaces, some technical, some business, but recognizing the fundamental challenge we have is that it is a complex area. There's a lot of competing concerns, but that if we can focus on value, we recognize it's difficult. We focus on value and focus on the opportunity that generative AI is actually giving us with these tools. I think there's a lot of benefit for us there. And with that, Shannon and Andy, I shall hand back to you guys for some Q&A.
Thanks, Ed. Can you hear me okay?
I sure can.
Yep, great. Thank you. Encyclopedic as usual, so much appreciated. I think there's a lot of challenges there, selfishly from ARDC's point of view, from the research perspective in terms of research reproducibility and integrity, and what infrastructure needs to be in place from our perspective. But I know there's data space people in the room here, and I invite you. Unfortunately, I don't have a roving mic, so I can either relay the question or if you want to come up and speak into the mic. I know there's a couple of questions out there. Any questions for Ed? Yeah.
So it was wonderful hearing about the dynamics of data quality. And I'm curious if Ed has any thoughts as to the scope of data spaces, given how context dependent and use case dependent those elements around data quality and standardization. How focused is a data space, or how focused should one be given this experience?
Could you hear that, Ed?
I sure did. It's actually a really good question. So how focused should it be? I think it needs to be as focused as the requirements of the participants in the data space are. So for example, sometimes we particularly in Europe, we have this very broad perspective of the mobility data space. That's very broad. That's everything in mobility. And if you're looking for traffic management solutions in a city, you need to have very, very high quality data because of the safety critical nature of what you're doing. But if you're just trying to find the fastest route from A to B as a user, the expectation on data quality can be a little bit less. So I think the key lesson there is trying to scope a data space, or even parts of a data space, that can actually share more of that context or have more common understanding of what that context is, will make it more successful for sharing data. And really it goes back to, who are the users, what's the shared value that they're identifying by participating in the data space, and now can we ensure that the data space is matching the context and the expectations in terms of data quality for those users.
Robin.
Nice talk, Ed. Rob Shen from MIT University. So it was one of your slides talked about the shifting from the sharing focus to the very focused part. And I guess my question will be, as a university staff, really exciting, in the futures, if we can really see the data space can unlocking or creating social or economic values on this part. But then my question is about non-technical, how to evaluate these type of values?
How can you evaluate them? Yeah, that's a really good question. So I think there's different ways of doing it, and it depends on, again, the specifics of the data space that you have. So for example, for a mobility data space, I would suggest that the value you're trying to measure there isn't about the data or the quality of the data, but rather what has been enabled by the data space. Have you reduced commute times? Have you reduced carbon footprint? Have you increased the efficiency of your transportation network? So I think the value centric part really has to go back to the user and the ultimately the underlying problems that you're solving with your data space. So like for a health data space, it's not about the amount of data that's available, but rather what are the improved health outcomes that you have by using that data space. I think that's the really important thing, because that ties it back to the motivation for the data space, the users that are there, and ultimately your funders or any funders or anyone that's investing in it will want to see those improvements. So that's the key thing from moving from not only saying yes, we're able to share data, but here are the real benefits that we actually have delivered for society, for companies, for individuals, for users.
Yeah, on that, to develop the value out of this, I come from a background of, say, urban digital twins, trying to build models of cities that eventually can govern themselves in an autonomous way, hopefully. That'll require a system of systems approach with simulations feeding in and trusting each other to a certain degree and having spotty, sparse data that they're interpolating, et cetera. If we take for a given the data spaces work and they're perfect and the data's flowing, how do you layer on top of that a system of models that take this data and where you can still control who runs the models, how they can work, kind of I don't know, a data space for models. Is that something that data spaces should cover? Or is that something a separate platform on top of should operate? I'm very curious about your thoughts.
Yeah, that's a great question. There's a couple of things there. So the first thing is, I never assume that the data space is perfect. Never assume data is perfect, because it never is. That's more of a philosophical thing. But I think at the start I showed you the interoperability framework that looked at kind of data process. I don't know, sorry, it was data, service, process, business. Fundamentally, a data space is only tackling that data layer, right? It'll start poking its fingers into the process, the service and the process a little bit, but it's not gonna, like, a data space isn't gonna have a service that says optimize traffic flow uh, in a city. It won't have that. So it becomes important for you, like if you're working on digital twins, system of systems, is to recognize that here we have is a piece of infrastructure that allows our systems of systems to exchange the data. However, they're still independent systems, and all of the systems of system engineering thinking that's needed still exists. It doesn't replace that, nor does it replace the need to build that twin and to build the actual system of systems itself. So it's a piece of the puzzle. It's a very important piece of the puzzle, but it doesn't replace the systems. It isn't a system itself. It won't run a city, but it will provide you with the information to maybe for the systems that do run cities that they're trying to build. It'll make life a little simpler. Ultimately, if you think of it, you wouldn't ask the same question uh, um, about connecting your systems to systems using the internet protocol. You just assume, yeah, that's what we do. We just, yeah, absolutely, we'll open a socket, we'll send over some packets, it'll figure out what it has to do. Effectively, that's what we need with data spaces, as well as that it becomes that kind of universal layer that's just there. It doesn't solve everything, and that's important, because the more we try to put into a data space services and application, I would call them application level concerns, the more likely it is it's going to fail. so that the cleaner we can keep it around just here's data governance, we'll try to support interoperability, the better. Now, having said that, the last part of your question was talking about models. And one of the points I was making in the talk is that because AI systems are so dependent, or at least the current generation of generative AI and data-driven AI, because they're so dependent on data and understanding data, and many of the problems that we see with them is through a lack of understanding of the data that's been used to train them. You know, it's more of a dependency for AI frameworks to connect and to leverage appropriate data spaces and kind of data frameworks when they're designing and building their models. So I would see AI models as just more of the application layer, but that for us to deliver value, we have to think of both of these things together.
Thank you.
Right, and I think we've got one more question.
Thanks.
I would venture from ARDC. It's great to be in contact again and to hear you today. So thank you for your time. Please put your crystal ball on. What do you see in 5 years that could change or disrupt the shape of data spaces as you see it?
I would say MCP is really exciting. And as I said in the talk, it's not about the technology, it's about the level of uptake. So if you look at HTTP, like it wasn't that exciting. What was exciting is that everyone started using it, and it became, ultimately it was a de facto standard, but it became, an actual standard with W3C. If we can have MCP, the uptake continuing on the curve that it currently looks like, that effectively is an international connector network to be able to connect to resources. Now, what MCP doesn't have is anything around the governance and the consent management, and that's really, really, really important. But in terms of if MCP can get widespread acceptance, which it looks like it's gonna, what we basically need to do then is to ensure that we have the data governance mechanisms around that. And then if you start looking at basically the whole agentic AI approaches, that can effectively give you very, very consumer friendly ways of interacting with the data space. So like ultimately, I'm looking at most likely researchers all in the room here. We're probably very comfortable with that, Yahoo taxonomy. Let's go find the data that we want, pull down the data, do something with it. We all love that. That's our bread and butter. That's what data scientists do. But the reality is your average user won't. It'll be a natural language interface. It'll be, I need to do this. Can you do it for me? And if you can have an agent go use MCP, connect into your data space, pull down the latest statistics from wherever, or the latest data from somewhere, and then help the user in creating the artifact that they want to create, I think that's all achievable easily in the next 5 years. So it's actually a very exciting time to be in this space. I think what the data space community can bring to the conversation that the agent people and the MCP people are not considering is the need for data governance and the need for managing data resources as well. So I think it's a case of trying to bring these worlds together.